Well, hello guys, Mr. G here, and today we're going to be doing questions on vertical projectile motion. Now, these questions are a little bit more challenging. There are going to be 3 questions, and in this work, there are going to be 2 projectiles moving at the same time in different direction or the same direction. So the way of approaching the problem is a little bit difficult. Now, the first question says a ball A is thrown vertically upward from height H with a speed of 15 meters per second. At the same time, a second ball B is dropped from the same height as ball A, as shown in the diagram below. Both balls undergo free fall and eventually hit the ground. And here is the picture of what happened. You have a ball A which has been thrown upward at 15 meters per second and a ball B which is being dropped from that height. Now, I want you to know something before we go on. We're going to take for this work the ground as the reference point. Now, if we do that, then the ground is going to be, for example, the initial position, the 0 reference point. And the initial position for both objects, the initial position for both projectiles is the same because both of them were dropped from the same or thrown from the same point. So this point here is let's use the Y because we are in the vertical projectile. This is the initial position for both balls, and the final position will be at the ground when they reach the ground. So here will be the final position for both of them when they arrive together. So this is a point important to have, and I'm going to write a very important formula, which is the position formula. The final position is equal to initial position plus displacement. All right, this is a very important formula that we are going to use not just in this question but in the upcoming questions. Okay, so let's go on because not everything we're going to use that one there. All right, the question 1.1, explain the term free fall. Calculate the time it takes for ball A to return to its starting point. Calculate the distance between ball A and ball B when ball A is at its maximum height. Sketch a velocity time graph in the answer book for the motion of the ball A from the time it is projected until it hits the ground. Clearly show the following, and then they give you 4 bullets to show them. So let's start answering the question here. Now, this is not the first time we speak about the definition. Free fall is the motion of an object under the influence of gravitational force only. And I'm going to highlight different the word only because it is an important word there. Make sure you don't forget to write only. The gravitational force is the only force acting on the object. Question 1.2, calculate the time it takes for ball A to return to its starting point. So now we're working with ball A. So in this question 1.2, what is the situation? We have an object A which has been thrown up, and this object is going to go up all the way to the maximum height. It's going to stop there and is going to return down to the starting point. Remember, the starting point is not the ground. Okay, so it's going to move down, move up and move down. What I want you to see something. The initial position and the final position for this object is going to be the same. So the displacement of this object is equal to 0 when it turns to the point of release. So saying that, let's write as usual the data we have. Now, what formula are we going to use? And this one here is the answer for question 1.2. So let's go to question 1.3. So here we are. Both balls were released at the same time. Ball A will reach the maximum height, and ball B, this one is ball B is moving downward. This is the ground. So to know the distance, note what they want to know is the distance between ball A and ball B when ball A is at the maximum height. So this here is the distance they are looking for, how far they are from each other. So all we have to do is to calculate the maximum height the ball A reaches, and to calculate in that time how far ball B goes down. Okay, so let's start by calculating how far, or the maximum height that ball A reaches, and what we have for ball A. So the data, and we're going to say up is positive for ball A. Okay, now note the following here. This time we calculated here. We may not use it, but later on we are going to. This is the time that ball A takes to reach the maximum height. Remember, previously in the previous question 1.2 we calculated the time the ball takes to reach the maximum height and back to the release point. And if the time to go up is the same, so you just divide it by 2. So this is the data, and with this data we can calculate the maximum height. So let's do that. And this here is how far ball A moves up from release point. So now let's calculate how far down is ball B when ball A is at its maximum height. The time will be the same. So I want to know in this time how far down is ball B. So let's do the calculation for ball B. And let's start with the data. Now for ball B, I'm going to say down positive. Remember, you can select and you can change the direction as you want. So for this one, we're going to say down is going to be positive. Okay, so what we have. What is the best formula we can use from here? And this is how far down is the ball. So how far are they from each other? Remember, we need to add now this little distance here for ball B, and we have to add this distance here for ball A. So we have to add both of them to get the final answer. So now to calculate the distance, you have to add the 7.475 plus the 11.47 meters of ball B. So they will be from each other a distance of 22.945 meters. And this is the final answer for this question. No, it's not that bad. It's not that bad. It's not intimidating because there's two objects, but it's not really that very bad. And now question 1.4 is an important one. We're going to sketch a velocity times graph for the motion of ball A from the time it's projected until it hits the ground. So only for ball A, that is the question. And then we must indicate the initial velocity, the time it takes to reach its maximum height, which we have it already, and the time it takes to return to a starting point. Only those is what the graph is required. So let's draw the axis. Okay, here is the axis, and we are going to take up as positive. So if up is positive, the object start moving with the initial velocity of 15 meters per second, and is going to be, let's write it here, 15 meters per second positive, because the object is going to move up, and I said up is positive. The velocity is going to decrease up until the maximum height. So from there, the object will be moving all the way up, but the velocity is going to decrease, so it's going to go up until the x-axis. There we go. Let's quickly fix that line. So this is what the ball A does. It goes there. Now this is 0. That is the velocity at the maximum height. What is the time the object or the first projectile took to reach the maximum height? and it was calculated in the previous question, so the time for the maximum height was 1,53, but the object obvious stops there but returns to the starting point. So the velocity at the starting point is 15 meters per second, but in the opposite direction, and the time will be the same. So here it continues up until starting point. There is the starting point, and if we go to the time here would be another 1,53. When you add together, that will be 3,06. That is the time the ball A takes to reach the maximum height and go back to the starting point. But the object didn't stop there. The object go all the way to the ground. So this graph does not stop there. It continues up until the object reaches the ground, but it was not part of the question. They didn't ask you to calculate the final velocity that the object will have at ground level, but it can be calculated. We're just not going to do it right now. And guys, this is the first question we done. It is not so bad. I hope you understand. Let's go to the second question. Question 2. Question 2 say a ball is projected vertically upward from the ground near a tall building with a speed of 30 meters per second. Ignore the effect of a friction. Question 2.1 explain what it means by a projectile. 2.2 calculate the total time that ball A will be in the air, the distance traveling by the ball A during the last second of its fall. Question 2.3 2 seconds after ball A is projected upward, ball B is projected vertically upward from the roof of the same building. Now this is a little bit more tricky than before. The roof, the building is 50 meters above the ground. Both balls A and B reach the ground at the same time. Refer to the diagram below, ignore the effect of friction. Calculate the speed with which ball B was projected upward from the roof. Sketch a velocity times graph for the motion of both balls A and B, and there is few things that must be represented on the graph. So this question, as we said, is a little bit more tricky, so let's start answer the question. 2.1 explain what is the mean by projectile. The first question they ask you about free fall, now they're asking you about projectile. So let's write the definition of projectile. So what is projectile? Projectile is an object, important, we are working about an object. Previously we said there was a motion that move under the influence of gravitational force only. Remember, only is very important, and it's the gravitational force. So it's the same, practically the same definition, but this one is an object. So let's go to question 2.2, calculate the total time that ball A will be in the air. The total time ball A is going to be in the air. Remember, ball A was thrown from the ground and is going to be all the way up and down. That is what they want. The total time ball A was in the air. So let's write the data we have for that question. Question 2.2.1. Now, final velocity when the ball is at the ground and will also be 30 meters per second. Remember, we learned about that one in a previous video. We have that G is equal to minus 9,8 meters per second square, and we are looking for the time. So quite simple. Formula. This is the total time the ball takes to reach the maximum height and return to the starting point. Guys, remember there are different options to solve this one, but I cannot do all of them. You can try other options and compare the answer. I'm not going to do all the possible options, okay? Now, question 2.1 or 2.2.2. Okay, this question could be a little bit tricky. They ask us to calculate how the distance traveled by ball A during the last second of its fall. So let's quickly, as usual, write the data. And we are going to take down as positive for this question because we are going to take the motion down. And by doing this, everything will be positive here. But let's write the data. All the formulas we can use to calculate displacement here. If you notice, in all these formulas to calculate displacement, we have the initial velocity. So we need that initial velocity. And therefore, the first thing we are going to do is to calculate that initial velocity for that last second. But it's quite easy, guys. So let's calculate that initial velocity using the formula. Final velocity is equal to initial velocity plus acceleration multiplied by time. Okay? Now we have the initial velocity of the object for that last second, and then we have all the formulas. Now we can use, in actual fact, all of them. So let's use the first one, which I find it very simple, and then will be like this. And the final answer is 25,1 meters. Alright, so that means that the object will move 25,1 meter in that specific distance or that specific time we are talking about. And this is the answer for that question 2.2.2. The question is not that difficult. There may be other options to do it. I find this one quite simple, but you can use any option you like. So let's go to question 2.3. 2 seconds after ball A is projected upward, ball B is projected vertically upward. Alright? So they have 2 seconds different in their time, and they're going to reach the ground at the same time. So that is important to know. Let's look here. When this ball is being projected upward, eventually it's going to go all the way to the ground vertically upward. So please have that in mind. We're working vertically. When that ball reaches the ground, this here represented by this vector is the displacement of ball B. Starting point was there, that is the initial position, the final position is the ground. So that one will be the displacement. Now the time is the one that it may be a little bit tricky here. They are telling you that ball A and B reaches the ground at the same time. Ball A and B reaches the ground at the same time, but ball B was thrown 2 seconds after ball A. So ball A was already moving when ball B was thrown upward. And this is, it's mathematics. You need to know that time B is going to be equal to time A minus 2 seconds because it was projected 2 seconds after. So time B will be equal to time A if you take 2 seconds from there. So time B in the A will be equal to 6,12 that was calculated previously minus 2 seconds. So time B, in other words, the time that ball B will be in the A will be equal to 4,12 seconds. So this is important to have in mind. The time that they reach the ground is the same, but the time of ball B is going to be 2 seconds less because it was thrown 2 seconds after ball A. Okay, so saying that, the rest of the work will be the same. The rest of the calculation will be not that bad. So let's, as usual, write data. We're going to take down as positive for this question. So let's write data here. What formula would be the most suitable one? And this is the initial velocity with which the ball B was thrown upward. And this is the most difficult part of the question, guys. Then is only the graph left behind, which is question 2.4. Now, question 2.4 here said, let's go to question 2.4. Sketch the velocity time graph for the motion of ball A and ball B on the same set of axes. Clearly label the graph for ball A and B respectively. Indicate the following in your graph: time taken for both balls A and B to reach the ground, time taken for by ball A to reach its maximum height. So let's draw the axes and then see how to draw these two graphs on the same set of axes. So here we have the set of axes. We know that ball A was thrown initially upward, that is why it's positive, at the velocity of 30 meters per second, and is going to reach the maximum height eventually there. We know the time, the total time was 6,12, so the time reaching the maximum height here was 3,06 seconds, and obvious that ball turned around all the way up until it reaches the velocity of 30 meters per second, but in the opposite direction. So this one is the velocity with which the ball reaches the ground. Now let's go to ball B. This one is for ball A. Now what happened to ball B? First, the initial velocity of ball B, according to what we got here, is 8,05, so it's less than the ball A, and this one is not accurate. Okay, so let's make it here, and that is equal to 8,05 meters per second. Now that ball was not thrown at the same time as the other one. It was thrown 2 seconds later. So when this one is at 2 seconds there is when this ball was thrown from that velocity. So that ball is going to go all the way down. Know that it must be parallel to this one because they have the same gradient, and it will reach the not the following. Let me do this one. It cannot stop there, because if you stop there, it didn't reach the ground at the same time. So both of them are at the ground at the same time there at that point. So this ball B must still go parallel to that line up until that point. This point here is the final velocity of ball B, or the velocity with which ball B reaches the ground. Note the two lines are parallel because they have the same gradient. All right, they have the same gradient, and let's write it somewhere here. They have the same gradient. Okay, so guys, this is the question. This is the whole question 2. We are done with question 2. Let's look at question 3 and now. So you know what, let's stop here. Let's stop here with the 2 questions, and then next time we'll do another question. 2 questions I think is enough, guys. This is enough. I don't want to make the videos too long, and if I add another question it will be too long. So we'll stop here. I hope this helped you. I hope these questions are clear for you. They are a little bit more challenging. Next time we are going to definitely do the experiment calculating the acceleration due to gravity using 2 different methods, and then we're going to do 1 or 2 more questions to practice. Thank you for watching. As always, Mr. G here. You can subscribe for the channel and write comments. Thank you, and see you next time.